So, good morning, everyone. Um, Welcome to our first online lesson, and I hope you guys are keeping well. And well, this is our first online lesson, and unfortunately for you guys, that our first online lesson has to be physical science, but I promise to make it interesting. The first thing I want to say is that this is a canned lesson, which means that it's recorded before you guys watch it. So you won't be able to ask any of your questions. But what I do suggest is that if you do have any questions, write them down for me and email them, and I will get to your questions as soon as possible. Okay, so let's start today's lesson. Um, we're going to be doing introduction into stoichiometry. Now, stoichiometry is a branch in chemistry which deals with a lot of calculations and is used in industry, and when you go to university, you'll be seeing a whole lot of, or you'll be doing a whole lot of calculations. And these calculations have to do with how much of the compound needs to be used or how much of a product you'll be gaining. So we'll be looking into these calculations and the formulae that you will be using. So let's look at a bit of revision. And I think in grade 9 you would have had to have done a molar mass. So what is a molar mass? A molar mass is the molar mass is the molecular mass or the mass number of an element. So when we looked at the periodic table, we saw that there were two numbers on each side of the symbol, and one number was the atomic number and one number is the mass number. So finish, or molar mass is the mass number, which is the bigger number, and it basically tells us how much the element weighs. Okay, so how do we calculate the molar mass? Well, if we're looking at the periodic table of elements, the molar mass is the bigger number. But when we're looking at molar masses of compounds, we have to add the molar mass of each individual element in the compound. So for example, if we have the compound H2SO4, which is the compound for sulfuric acid, you'll notice that there is two hydrogen, one sulfur element, and four oxygen elements. So what we'll need to do to get the molar mass of that compound is we have to add the molar masses of the individual elements. So we look at hydrogen, which is 1.008, which we round off to 1. Then we look at sulfur, which is 32.07, which we round off to 32. And then we look at oxygen, which is 16 grams per mole. So to calculate this, we add our individual molar masses. So you'll notice down there on the screen that we have 2H. That 2H represents the two hydrogens that are in our compound, which is the two hydrogens. And we have one sulfur, which corresponds to that sulfur there, and we have 4 times O, which is the 4 oxygens, which means we will be saying 2 times 1 plus 32, because we only have one sulfur, and 4 times 16, and that will give us a total of 98.09 grams per mole. And that is the SI unit for molar mass, which is grams per mole. Now we're going to move on to the number of moles or the mole concept. So the number of moles can be defined as the unit of measurement that determines the exact amount of substance. We're going to stop there and we're going to analyze that statement. What this means is that it gives us an exact amount of how much of a substance is present. We could have 15 grams or we could have 15 milliliters of a substance, but it won't tell us exactly how much of that substance is there. So number of moles tells us how much of this substance is present, how much we have taken out. And the unit for number of moles is mole. Number of moles can be calculated in three ways. So I'm sure you guys know these triangles. They make it quite easier to understand formulae. So number of moles, which is N, equals to mass over molar mass. So small m is mass of the substance, big M is molar mass of the substance. That is way number one, where we use mass. Okay, number two is number of moles equals to volume over molar volume. So V is the volume of the substance. V subscript M is molar volume at STP. Now STP is standard temperature and pressure, which is your room temperature and pressure, and your room temperature would be 25 degrees and your room pressure would be 101 kilopascals or 1 atmosphere. And the molar volume of any substance at STP is 22.4 decimeter cube. And the last way to calculate number of moles is by using particles. So number of moles equals to number of particles divided by Avogadro's number. Now Avogadro's number equals to 6.02 times 10 to the 23. Avogadro's number basically tells us of the number of particles that should be in 1 mole of any given substance at STP. So let's look at some calculations. Okay. So calculate the number of moles for 20 grams of sodium chloride. So what we've been given is the mass of sodium chloride and we've given the compound. So what we can do now, or what we have to do now, is that we have to change sodium chloride from words to its chemical formula. So that is NaCl. Now we have to calculate the molar mass. Okay, so number of moles equals to mass over molar mass, and please you have to write your formula, otherwise you don't get any marks in your test or exam. So please write the formula so that the examiner knows what you're doing, or at least has the idea that you know what you're doing. So number of moles equals to mass over molar mass, and that's 20 grams divided by 58 grams per mole. Now that is the molar mass for NaCl, and that gives you a total or an answer of 0.34 mole. Let's look at another example. Calculate the number of moles for 14 decimeter cube of water at STP. Now we're using our volume, okay? So number of moles equals to volume over molar volume. and that is 14 decimeter cube over 22.4 decimeter cube per mole, which equals to 0.63 moles. And our last one is we're calculating the number of moles of an element using its number of particles. So number of moles equals to number of particles divided by Avogadro's number, and that equals to 1.63 times 10 to the 23 particles over 6.02 times 10 to the 23 particles per mole, and that gives us a total of 0.27 moles. So these are how these formulae work, but we can also use these formulae interchangeably. And what I mean by that is that number of moles equals to mass over molar mass. And from that we can also find our volume and vice versa. So I can give you volume figures and ask you to calculate the mass of the substance, which is an example that we have here. So the mass of aluminium oxide, so the question asks, calculate the mass of aluminium oxide when a beaker is filled to 150 centimeter cube at STP. Now, we have to convert that centimeter cube to decimeter cube because that is the unit we use for volume. So we have 150 centimeter cube, and centimeter cube is the equivalent of a milliliter, and decimeter cube is the equivalent of a liter. So what we're going to do is we're going to divide by 1,000 to get our decimeter value. So the first thing we're going to do is we're going to write down our formula. Number of moles equals to volume over molar volume. Now we have our volume, which is 150 times 10 to the minus 3, and this times 10 to the minus 3 represents 1,000. So we're basically dividing by 1,000, like I said before, to get our value in decimeter cube. And we're dividing this 150 times 10 to the minus 3 by 22.4 decimeter cube per mole, which is our molar volume at STP. And we're going to get an answer of 6.69 times 10 to the minus 3 mole. Now you can leave it in scientific notation or you could put it in decimal notation. It doesn't really matter as long as you get the right answer. So that is our mole. Now we have to calculate the molar mass of the compound because we want mass, and our mass equation requires molar mass. So we have two atoms of aluminium and three atoms of oxygen. And aluminium on the periodic table is 27 gram per mole, and oxygen is 16 gram per mole. So we have 2 times 27 and 3 times 16, which gives us a total of 102 grams per mole. That is our molar mass. Okay. So now we have our molar mass, and to get our mass, we need to use the same number of moles that we calculated here, and we can use it to calculate our mass. So let's write down our formula. Number of moles equals to mass over molar mass. And we have to rearrange the formula, but first you plug in all your values so you know what you're calculating. So our number of moles for aluminium oxide is 6.69 times 10 to the minus 3 mole. That equals to mass, which we're calculating, over the molar mass, which is 102 grams per mole. So if we rearrange the formula, we get the subject of the formula being small m, which is our mass, and that equals to 6.69 times 10 to the minus 3 mole times 100 grams per mole. And now, if we put that in our calculator, we're going to get an answer of 0.68 grams of aluminum oxide. So that's how we interlink the number of mole formulae. I could give you an example where we use number of particles and we could find mass. Or I could give you volume and ask you to find the molar mass of a compound, and I'd give you the mass for that. So these formulae are quite interchangeable and used quite often together. Okay, so let's move on. Please, if you do have any questions regarding these, please drop me an email and I will respond to them. Okay, so let's move on. So our next section or segment of this lesson is looking at reactions and limiting reagents. Now, from grade 9, we would have known that a chemical reaction consists of reactants and products, okay, or reagents and products, where we mix two reagents and we get a single product or many products. And that is the basis of any chemical equation. So let's look at an example. We have H2 plus O2 equals to H2O. Now, hydrogen and oxygen are our reagents, and water is our product. But this formula or this chemical reagent isn't complete. We have to balance it because if you look at the right hand side, you have two hydrogen and you have two oxygen. And if you look at the left hand side, for the let me rephrase. If you look at the left hand side, you have two hydrogen and two oxygen on the reagent side. And if you look at the product side, you have two hydrogen and one oxygen. So there's no balance really in that chemical equation. So we have to balance our chemical reaction equation. So what we do is we put a 2 in front of our hydrogen so that we put a 2 in front of our water so that the 2 is distributed to the hydrogen and the oxygen. So that gives us 4 hydrogen and 2 oxygen on our product side. Sorry. And we put a 2 in front of our hydrogen on our reagent side to give us 4 hydrogen. Now if we look at that chemical formula, we have 4 hydrogen on the reagent side and 4 hydrogen on the product side, and we have 2 oxygen on the reagent side and we have 2 oxygen in our product side. So that's one thing you have to be careful for, is that all chemical equations need to be balanced. In stoichiometry, if your chemical equations aren't balanced, your calculations are going to be wrong and you're not going to get the full amount of marks that you can get. Okay, so please remember to balance your chemical equations. So let's move on. We're looking at the limiting reagent, and the limiting reagent is a reactant that is completely used up in a chemical reaction. So let's think of it like this, right? We're trying to make a packet of Simba chips. That's probably 150 grams, those small, tiny packets of Simba chips. We're trying to make that, right? And in order to make that, we need a potato and we need oil. And when we put the potato into hot oil, the chips fry and we get the Simba chips that we need. So if we have one potato, let's say one potato makes one bag of Simba chips. If we have one potato, when we put it into the oil and when the oil fries the potato, We're going to get our chips, but there's still oil left over, right? So our our potato actually limits the amount of frying that happens to make the Simba chips. We could have all the oil in the world, but we need one potato for one Simba chip, one packet of Simba chips. So our potato now becomes a limiting reagent to that reaction. I hope you clearly understood that. Okay, so these reagents or these limiting reagents are important because it determines the amount of product that will be formed at the end of the reaction. Yes. So like I said with the potato, it determines how much. So we have one potato, we slice that up, and that potato gives us 150 grams of Simba chips when fried in the oil. So yeah, it determines how much of the product we get. So how do we determine the limiting reagent? Okay, so we're going to look at an example. So determine the limiting reagent when 16 grams of zinc chloride reacts with 10 grams of magnesium sulfate. So there's a lot of things going on in just 1 1/4 lines of a sentence or question. One thing you need to know is that you need to be able to you need to be able to write up chemical compound, molecular formula, not molecular, chemical formula. You need to be able to write chemical formula, right? So the question gives you the compound in words. You need to take that word and translate it into its chemical formula. That's one thing you need to know. The next thing you need to know is that you have to draw up a chemical equation. So zinc chloride plus magnesium sulfate gives you your products. That's the second thing you need to know. The third thing you need to know is what values are they giving you to determine our limiting reagent. And like I said, that in all of these calculations, we will be using number of moles. So the first thing you have to do, or one of the first things you have to do, is determine the number of moles. So we've been given mass, which means we have to use mass over molar mass to determine our number of moles. So let's look at the step-by-step guide on this, okay? So step one is write a balanced chemical equation. So what is zinc chloride? Zinc chloride, so if we remember from our symbol and valency table, zinc has is a 2 ion plus charge and chloride is a Cl minus charge. So and magnesium is a 2 plus charge and sulfate is a 2 minus charge. So zinc chloride would be ZnCl2 and magnesium sulfate would be MgSO4. And our products, we will end up getting zinc sulfate and magnesium chloride. Okay, now, is the equation balanced? That's what we need to know. So let's look at it. We have on our reagent side one zinc atom, and on our product side we have one zinc atom as well. And on our reagent side we have two chloride atoms, and on our product side we have two chloride atoms. Let's look at the other reagent, magnesium sulfate. We have one magnesium on the reagent side, and we have one magnesium on the product side, and we have one sulfate. We have one sulfur, and we have one sulfur on both sides, and we have four oxygens on the reagent side and four oxygens on the product side. which means that that is good news, that the equation is balanced and we don't have to add any more numbers. Okay, so step 2, determine the molar masses of each of the reactants. So ZnCl2, we have 1 zinc and 2 chloride atoms, and the molar mass of zinc is 91, and the molar mass of chlorine is 35, and we have two of them, so that's 2 times 35, and if we add those up we get 161 grams per mole. Okay, and our next reagent is magnesium sulfate, and the magnesium sulfate compound is made up of 1 magnesium, 1 sulfate, and 4 oxygens. Okay, so magnesium is 24, sulfur is 32, and oxygen is 16, and because we have 4 oxygens in the compound, we're going to multiply it by 4, and that molar mass, and if we add that up, that will give us 120 grams per mole. So step 3, determine the number of moles. In stoichiometry, number of moles is the currency. Like how we have rands here, we won't accept dollars, or we won't accept pounds or euros. In stoichiometry, we won't accept anything else. So convert everything to number of moles using our 3 number of mole equations. If you're given volume values at STP, convert them to number of moles. If you're given particles at STP, convert them into moles. You will get marks for calculating the number of moles. Okay, so number of moles for zinc chloride we'll look at first is mass over molar mass. We calculated the molar mass to be 161, and the question said we have 16 grams of zinc reacting, and if we put that in our equation, 16 divided by 161, we get 0.099 moles of zinc chloride. Now let's look at magnesium sulfate. Number of moles equals to mass over molar mass. We have 10 grams of magnesium sulfate, and we have 120 grams per mole as our molar mass, and that gives us a number of mole value of 0.083 moles. Okay, now step 4 is to divide the number of moles by the stoichiometric ratio. So 0.099 divided by 1 equals to 0.099, and the same for magnesium sulfate. So remember what I said about the potato chip and the oil, right? We have only so much of potato, but we have a whole lot of oil, and the oil is in excess once the product comes out. So if we look at this value here, we need to say that, okay, 0.083 moles of magnesium sulfate is going to react with 0.099 moles of zinc chloride. Now, all of our magnesium sulfate is going to be used up, okay? And it's going to leave 0.016 mole of zinc chloride, which means that we're going to have zinc chloride left over. That means our limiting reagent is magnesium sulfate. Okay, so the one is taken from the balanced chemical reaction, and as we discussed right now, magnesium sulfate is the limiting reagent because all of it gets used up in the reaction. Okay, so we're going to look at one more example, okay, where we determine the mass. of a compound. Okay, so the question reads 15 grams of sodium chloride reacts with 10 grams of calcium hydroxide to form sodium hydroxide and calcium chloride. Determine the mass of sodium hydroxide. So this is a typical test or exam question, right? A lot of information has been given. So what I suggest you write down is you write down the chemical formulae for our compounds. So we have sodium chloride, which is NaCl. We have calcium hydroxide, which is CaOH2 to form sodium hydroxide, which is NaOH. And we have calcium chloride, which is CaCl2. And they want us to determine the mass of sodium hydroxide only, because if you look at it, the question says we have two products, okay? So we only want the mass of one product. Okay, so step one, we write a balanced chemical equation, and that is NaCl plus Ca open bracket OH2 equals to NaOH plus CaCl2. Now to balance that, I know it's balanced already, but let's look at our balanced chemical reaction. We have two sodium on the reagent side, and we have two sodium on the product side. We have two chlorine on the reagent side, and we have two chlorine on the product side. We have one calcium on the reagent side, and we have one calcium on the product side, and we have two hydroxide on the reagent side, and this 2 on the product side is distributed to the OH, which means we have two hydroxides on the product side. So our chemical equation is balanced, which means we can proceed. Now, determine the limiting reagent. Okay, now we have to calculate our molar masses. Okay, I didn't do those steps, so on when you guys are writing out these notes on the side, you can calculate your molar masses, and I'm sure you guys know how to do that. But if there are any problems, you send me an email and I will get to it. Okay, so we have 15 grams of sodium chloride, and we have 58, and our molar mass is 58 grams per mole. And if we look at the calcium hydroxide, we have 10 grams of calcium hydroxide, and the molar mass for calcium hydroxide is 79 grams per mole. And our number of moles is 0.26 mole of sodium chloride and 0.12 mole of calcium hydroxide. So the next step was to divide the reagents by their stoichiometric number. So if we divide the number of moles of NaCl by 2, we're going to get 0.13. And if we divide calcium hydroxide by 1, we're going to get 0.12. Now 0.13 is greater than 0.12, so that means that there's going to be 0.01 of sodium chloride in excess, and that means calcium hydroxide is our limiting reagent. Okay, now determine the number of moles of product from the stoichiometric ratio. Okay, so we're going to look at the stoichiometric ratio, and we have to use the limiting reagent here. We can't say that the number of moles of NaCl is going to equal to the number of moles of the product, because we're going to have leftover NaCl. And how it works in chemical reactions is 1 mole of product, 1 mole of reagent is used to form 1 mole of product. Okay, so our limit in all calculations with limiting reagents, when we cross over to the product side, we have to use the limiting reagent value. Okay, so we're going to use 0.12. Now, if we look at the chemical equation at the top, our calcium hydroxide is 1 and our sodium hydroxide is 2. So that means that 1 mole of calcium hydroxide reacts to form 2 moles of sodium hydroxide. Okay, so the number of moles of calcium hydroxide equals to double the amount of the number of moles of sodium hydroxide. So we're going to have to multiply our number of moles by 2, and that number of moles was calcium hydroxide. So we're going to take calcium hydroxide, multiply it by 2, and we're going to get the number of mole value for the product sodium hydroxide, which is 0.24 moles. Okay, now we're going to determine the mass of the product, and the product that we're looking for is sodium hydroxide. So NaOH and number of moles equals to mass over molar mass. And again, please on the side calculate the molar mass, that way you get good practice. So we have the number of mole value, which is 0.24 moles. We're looking for the mass, and we have the molar mass value, which is 40 gram per mole. So if we rearrange the formula to make M the subject, we're going to get number of moles times molar mass, which is 0.24 times 40 gram per mole, and that will give us 9.6 grams of sodium hydroxide. So in our reaction of sodium chloride and calcium hydroxide, the amount of sodium hydroxide that is produced is 9.6 grams. So I think that is the end of our lesson. Yes, I will be sending out an activity on calculating the number of moles and calculating the limiting reagents. We will also have an activity with um, balancing reactions and calculating the molar mass of compounds and writing chemical compound formula. Okay, so if you guys do have any problems with that, my email is open and I will get to it as soon as possible. Okay, thank you guys for coming. This is a canned lesson, so it will be uploaded onto Google Student. Okay, thank you. Bye.